In this session, I'll be introducing more on Stata graphs. Previously, I have focused on introducing the graphical methods for describing qualitative data, the bar graph, the pie chart. And in this session, I will be introducing the graphical methods for describing qualitative data, primarily the histogram. Also, I will be introducing some other graphical methods other than histogram for assessing normality. And in the end, I will talk about and introduce the concept and the graphical method for bivariate relationships. This will prepare us for the third part of the course in terms of using Stata for examining relationships. Let's first look at the comments for creating a histogram. So if you launch Stata, today we're going to use data that is from the internet. So if you type the comment web use auto, we will actually automatically load a data set on automobile data. This is already stored on the internet, and we can directly use this web use comment to get this data. Also, once you have this data successfully loaded, let's take a look at the data plotter. So we have several quantitative data with numerical values. This is very easy to tell. On the other hand, we have another qualitative data showing the make of the cars, and each cell we have a text here. That's why the column of the variable are shown in red. We do have another qualitative data which is showing that whether this car is a domestic or a foreign. However, if you notice that now the color of the text is in blue instead of red now. This is because that this text field is already encoded into a numerical field. Okay, so if I quickly do a summarize, so sum all the variables, you see that this make variable, still we do not have any descriptive statistics. We cannot find its mean and so on. However, this foreign, although it seems like this was still a qualitative data because the values are domestic or foreign, but actually if you see them in blue, this variable is already coded as 0 or 1. And because the name of the variable, instead of being country of the car, now is named as foreign, so probably the way that it encodes this variable is just 1 being foreign and 0 being domestic. Sometimes you may not directly know how a qualitative data has been encoded into a numerical or quantitative data. So the way to look at the assigned value for each category is to examine the frequency table. So if you tab foreign, you see the frequency table for qualitative data or categorical data. As before, we have two categories, domestic and foreign. We have some frequency here. And at the same time, you can also, because it's already encoded with numerical values, so you can also use tab foreign with an option that's called no label. And if you go that, you can directly see, okay, 0 is associated with the category domestic, and 1 is associated with the category foreign. So actually, you can directly understand what numerical values has been encoded or assigned to each category. Okay? So for now, whenever, for example, you're trying to sum the MPG using an if option, you can directly do sum MPG if foreign is 1 and sum MPG if foreign equals to 0. you do not have to use the text where you say foreign equals to double quotation domestic or foreign equal to double quotation foreign, because these are already given a value of 1 and a value of 0. Okay, so now let's construct a histogram. So the basic comment is just histogram, for example, MPG. And if you just click enter, you can quickly get a histogram with some appropriate number of levels selected by Stata. Okay, so the abbreviation for the histogram is called HIST. So HIST-MPG. You can still find the exact same histogram. Okay. We do have some options here. So for example, the default histogram, you have the density on the vertical axis. If you'd like to show frequency, then you can use frequency. You can also override its default and arbitrarily assign the number of intervals. And that option is called bin and then the number. So for example, we can do histogram MPG, comma, frequency. So now on the left-hand side, you have frequency. Alternatively, you can also say, I'm going to want only 5 bins or 5 intervals. So this will only give you 5 intervals. Remember the difference between a histogram and a bar graph. Usually we do not have space between the bars. Okay. Of course, you can use multiple options if you'd like, and there's no need to have multiple commas. So just 1 comma, I want to have frequency and then a number of 5 intervals. And another very good option is to create a histogram and also fit a normal curve. If you recall that histogram is the primary graphical method for assess normality, right? And for example, I can now construct an histogram with 3 additional options. So I'm going to create histogram MPG, comma, frequency, a number of 10 intervals, and also fit a normal curve. So if you enter, you will see this constructed histogram. Of course, you can comment that although we can still fit a very nice normal curve, but probably this is not perfectly normal. It's still somewhat asymmetrical and so on. But sometimes for very large sample size, we'll think that this is good, approximately normally distributed. So the last one that I'd like to show you is, if you recall previously in our bar graph, we could actually create a bar graph for qualitative information over different categorical data. So for example, we created some mean study hours or wages across different gender, right? We could actually also do that for the histogram. But in the comment, the option comment, previously it was over the categorical variable. Now we are going to use by and then the categorical variable. Make sure that you only have these categorical variables. It can be a quantitative binary variable, but make sure that you are creating histogram across 2 different categories. For example, we do have a very nice categorical variable foreign, so we can create a histogram that shows MPG across domestic cars and showing domestic cars and foreign cars. So it's going to be histogram MPG, comma, by foreign. And then we're actually going to have 2 histograms across 2 different categories. You could do that if you have 4 categories or 3 categories. It will just create 4 histograms or 3 histograms. You can continue to add more options. For example, you want to create a histogram over foreign, but also include a normal curve. So this would work. Okay. So creating a histogram. If you recall from the normal distribution chapter, we did talk about that there are a number of ways to look at whether your data are from an approximately normal distribution. So for example, some of the numerical method is where you can compute the intervals, 1 standard, 2 standard, 3 standard deviation above and below the mean, and to compare with the empirical rule. Alternatively, you can also look at the IQR, but still the primary way to assess normality is through constructing a histogram, or maybe stem and leaf display. Previously, we introduced briefly. Another way to assess normality, which I find it to be very useful, is to, number 4, construct a normal probability plot for the data. And actually, the comment is also very simple. You just need to type the comment P norm. So a probability plot, P norm, and then the variable that you want to look at whether the data of that variable is normal. So for example, let's look at the P norm for MPG. So this probability plot always have like a linear line that shows that if the data is very normal, all the data point will align very nicely with this line. And if the data is not very normal, you will see some deviation of the data points from the line. In this case, I would say the deviation is not a lot, so we can still probably think that MPG is approximately normal. Okay? So if we assess another variable, for example, P norm price, you see that the price actually deviates from this line a lot more. So I would say that the price is not a very good normal distribution and so on. So if we look at the histogram for price, probably we'll see a much more skewed histogram. It looks like this. Okay. So this is the alternative way to look at normal distribution, the P norm comment. In the next, I want to spend some time to talk about using data or statistics to examine bivariate relationships. So when we talk about bivariate relationship, we're really trying to examine the relation or association between 2 quantitative variables. We want to look at, for example, whether the travel time and distance to campus are correlated, related, or associated. Usually these 3 words are somewhat interchangeable, although we mostly use correlation in statistics. Alternatively, we may also be interested to look at whether crime rates and employment rate are correlated or not. And other than looking at whether they are correlated, we do want to look at, for example, maybe three questions. Whether the relationship or the correlation is positive or negative, whether they're positively correlated or negatively correlated. We also want to know how strong is the relationship. And the third question, sometimes we want to figure out whether the relationship is linear or nonlinear. A linear relationship can be represented by just a linear curve, right? Or a straight line. And a nonlinear relationship can be represented, for example, by a U-shaped curve or an inversed U-shaped curve. So the relationship could be positive first, and then after a certain point, it becomes negative. Or maybe it's negative first, and then after certain points, we sometimes call it a turning point. And after that turning point, it becomes positive. So that if that's the case, we have a non-linear relationship. So in terms of examining the bivariate relationship, I'd like to first introduce a numerical method that is called a correlation coefficient. So we could calculate a correlation coefficient on between the two variables. I have attached the formula, mathematical formulas for calculating this R here, as you can take a look at and intuitively understand that this correlation basically is calculated through the individual values, how it deviates from its own mean, and multiply and sum together over some summed square and so on. Right? And also this is actually a ratio. So correlation coefficient actually always take a value from 0 to 1, or it can be negative, so from -1 to +1. If it has a positive sign, that implies a positive relationship. And if it has a negative sign, it implies a negative relationship. If this R is 0, then that just implies no relationship, no correlation at all. And then any number between 1 and 0 or 1 and -1 just shows the magnitude of the relationship. So if it's closer to -1 or 1, the stronger the linear relationship we have. And we can say that they are strongly correlated. And if it's closer to 0, and the weaker the linear relationship we have. So be a little bit careful here that whenever we are constructing a correlation coefficient, we are always assuming a linear relationship. So the magnitude of the coefficient is really about how strong the linear relationship, either negative or positive, is, or how weaker the linear relationship is. In terms of the interpretation of the correlation, normally we want to first interpret whether the relationship is negative or positive, and then we want to comment on how strong or how weak the relationship are. In this slides, I just attached a table on some rule of thumbs for interpreting the correlation coefficient. So for example, 1 being perfect correlation, 0 being no correlation at all. If the coefficient is between 0 to 0.2, very weak correlation to weak correlation, moderately strong correlation, and very strong correlation. On the other hand, this is just some guidelines in the textbook or the Stata manual. However, in the real world empirical research, I also see, for example, the authors interpreting a correlation coefficient of 0.3 to be moderately strong. And for example, an correlation coefficient as of 0.65 to be very strong correlation. So in the real world, sometimes the interpretation may vary in different field and also in different by different authors in different communities. You know, sometimes it's very difficult to have strong correlation in certain field or in certain relationships. So whenever they find some relatively high number, they already think that they have evidence for a very strong correlation. So whenever you read papers or reports, take a look at their correlation coefficient and how they interpret it. It's not absolutely wrong. I would feel like sometimes it's only a relative concept. Okay. So let's talk about how we could use Stata to calculate the correlation coefficient. As you see from the formula, if you have a large data set, calculating individual values from its mean, take the square and then take the sum can take a long time. But the Stata comment is very simple. You just need to type CORR, which stands for correlation, and then tell which two variables you'd like to examine. For example, we can quickly examine the correlation between price and MPG. And enter. We see that this correlation is shown as negative 0.47. So this shows that price and MPG are negatively correlated, and the magnitude of the correlation we would say is probably strong or moderately strong. Okay. We can also look at, for example, the correlation between price and headroom. So now we have a positive correlation. So price and headroom, which is headroom in inches, are positively correlated. However, the magnitude of the correlation is not very strong or is relatively weak, and so on, right? So sometimes when you want to look at a bunch of variables and their correlation all together, you can actually continue to add more variables in, followed by this CORR comment, and Stata will create a correlation matrix for you, and you can interpret all the quantitative variables and its relationships all together in this matrix. So for example, let me just build a correlation matrix for all the quantitative variables I have in my data. So I'm just going to click all my quantitative variables. Foreign is already encoded, so it's a quantitative variable. And now if I click enter, you see that we have a, it's in the second row. Let me do one more time. Maybe take out the foreign, so it's easier to read. So now we see a correlation matrix, like lower triangle here. But this matrix allows you to examine any correlation, the correlation of any two variables that you'd like to examine. Okay. So for example, we want to look at, it seems like the displacement in MPG has some very high correlation. MPG with weight also very high correlation, but negative, and so on and so forth. So sometimes we may want to report some of the correlation matrix to see all of the variables you examined and what are the bivariate relationship we have. Okay. So in the next, I'd like to introduce another very good graphical method to look at this bivariate relationship, which is to produce a scatter plot. So the scatter plot is just a two-dimensional plot or two-variable plot, where you have one variable on the vertical axis and another variable on the horizontal axis, and Stata will plot each data point, the pair of variable 1 and variable 2, on the graph. And by looking at the pattern of all the scatters, we can examine whether it's a positive, pretty clear positive relationship or a negative relationship, or maybe the scatters are just pretty messy all over the place, and we would assume that there's no relationship. So one of the advantages of this graphical method of producing a scatter plot compared to looking at the correlation coefficient is that we can basically examine if there's any non-linear relationship. So if the plot shows some U-shape or inverse U-shape, we could probably tell that there are some non-linear relationship. Okay. So the comment for creating a scatter plot, which is actually still the two-way comment, previously, if you recall, I did introduce a two-way plot that's called the two-way line. So if you go to the unemployment assignment, I previously asked you to create a two-way line plot on, for example, Germany and date. So in this case, we have Germany, the unemployment rate on the vertical axis, and date on the horizontal axis. Of course, we're not really examining the correlation between Germany and date. We just want to look at the Germany's unemployment over time, but still this is a two-way line plot. And also, whenever we are producing some two-way plot, the first variable given is going to be always on the vertical axis. So the second variable given is going to be always on the horizontal axis. That's why in my slides here, instead of writing them as 1, 2, I call them variable y and variable x, just to remind you that the first variable is going to be graphed on the y-axis or vertical axis. Okay, and if you also recall that if you'd like to add more plot, you can continue to add another line plot that would be enclosed in the parentheses. So we could also say we want to create Spain and date, another line plot, UK and date, another line plot, USA and date, another line plot, Japan and date. Line. I do need to say what type of two-way graph that needs to be required. If I enter, I'll see 5 line plots. So whenever you want to build multiple two-way plot, you just put all the comments in a parenthesis followed by a general two-way comment. Okay. This is actually the same for a scatter plot. But of course, we do not want to include multiple scatter plots, not like multiple line plots. So usually, what we want to do is to just do a two-way scatter plot on variable y and variable x. For example, let me do two-way scatter. Let's probably still do price and MPG. Click enter. So this is just a two-way scatter plot. So if we have, how many variables do we have? So if we have 74 variables, you should be able to see 74 data points here, okay? And you can also kind of observe the relationships. A little bit messy, but it's negative, right? On the other hand, it's actually very useful to sometimes create another fit line to help you to read your scatter plot. Remember, we do not usually produce multiple scatter plots, but we can create a scatter plot together with a linear fitted line plot. So L-fit stands for linear fit. So if we do that, so a two-way scatter plot on price and MPG, and at the same time create a linear fit plot to see if price and MPG fits a linear line altogether. If I click enter, you will see that so we have a scatter plot and a linear fitted line plot produced for you at the same time. So you could look at that more or less we do have a negative linear relationship here. I think the scatter plot, although a little bit messy, it still fits the linear line pretty well. And by looking at the correlation coefficient, we knew that it had some negative correlation there. Okay. Alternatively, sometimes you could also check if maybe the bivariate relationship can be better presented by a non-linear relationship. This is where you could use Keough fit. This is where you fit your two variables according to a quadratic relationship, a quadratic fit. So now if we're going to do a two-way scatter plot and at the same time create a quadratic fitted curve, click enter, we'll see actually probably the relationship between price and MPG fits better for a non-linear relationship, meaning that the correlation between the two variables are negative first, but after the mileage is across 30 something, after some turning points, the relationship could be positive. But still, we want to be a little bit careful when using this because we do not have so many observations above 30. But still, this gives us an initial impression on the correlation between the two variables we're interested in and whether how strong the relationship and whether the relationships are linear or non-linear. Okay, so scatter plot. The last thing I want to talk a little bit about is this general graph comment on creating two variables, or a bivariate relationship. So the general comment is called two-way, and we talked about that you can produce a two-way line graph or a two-way scatter graph. So the most standard Stata comment would be two-way line variable 1, 2, or two-way parenthesis scatter variable 1 and 2. In fact, there are some variations in this two-way comment that you might see in other Stata manuals or other introduced by other professors. So if you're using this two-way comment and you're also only producing one graph, one plot, only one line or only one scatter, you may skip this parenthesis, okay? So for example, let me do two-way parenthesis line UK date. You see this unemployment of UK over time. But alternatively, if you're just plotting this one line, you can skip the parenthesis and do two-way line UK date. You see the exact same graph, okay? Actually, you can even skip this two-way comment and directly say I'm going to create a line, two-way line plot. So if you do line UK date, again, you're going to have exact same graph. So in some Stata manuals and in some textbooks, actually a line comment and a scatter comment were introduced. But the most general comment is actually called two-way line and two-way scatter. But if you see that, it's actually some identical comments. Okay? Alternatively, whenever you're going to produce some multiple line plot or some multiple scatter L fit, Q fit plot, you do need to include this parenthesis, okay? So for example, two-way and then one scatter plot in the parenthesis and another linear fit plot in the parenthesis. So if you're going to use the line comment or the scatter plot comment without including the two-way, so the way to do that is to use this two little vertical line. So for example, if you do, let's say, if you skip this two-way comment directly to say line UK date, line USA date, and you click enter, you're going to see an arrow because you cannot have a parenthesis in the beginning of a comment line. So if that's the case, you're just going to do line UK date and two vertical line and another line US date to produce multiple and two line plots. Okay. So same for the scatter. So you could skip the two-way comment, produce a scatter plot on price and MPG, and at the same time produce a Q fit plot on price and MPG. So without using the parentheses, you let this true vertical line to connect this multiple plot comment. Okay, if you click enter, you're going to see the exact plot we talked about previously. So the last thing is, if you go to the Stata graphic menu, you can also look at this two-way graph, click some buttons and create the graph. You can maybe explore it by yourself, but basically, if you go to the menu, graphics, and you have these two-way graphs. The most used two-way graphs are the line graph and the scatter plot. So if you click on that, you can actually create plots, right? So if you want to create one scatter plot, you have so many options where you can explore yourself. So in this fit plots, you can create some linear fit and some Q fit, quadratic fit, right? So for example, now I'd like to create a scatter plot where my variable y is price, my variable x is MPG, and if I click accept and then accept, I'm going to see that scatter plot as before. And actually, Stata will automatically generate this comment for you, even though you used those buttons there. So alternatively, you can go back to the two-way graph. You may want to edit it, or you may want to disable it, right? But now, for example, I want to create another graph where I want to add a quadratic fitted line for price and MPG. So if I click, now I'm producing two plots at the same time. So if I click OK, you're going to see this plot. Alternatively, if you disable the first plot, disable, and only the second plot will be shown for you. So click OK. You just see a non-linear fitted curve for you. The comment generated is only the two-way Q fit, price, and MPG. Okay, I do not recommend you to rely too much on the Stata menus, but really learn about the Stata comment and use produce everything using Stata comment. But feel free to take a look at of this Stata graph and so on. Previously, I also introduced bar chart, pie chart, histogram. You can also use this menu to create them. Okay. So that's all I want to introduce. Just one little note on the bivariate relationship. Sometimes we do call them correlation analysis. It does have a number of limitations. First of all, it assumes a linear relationship between the two variables, and this is especially true for the correlation coefficient. Also, it does not tell us anything about the mathematical relationship between the two variables. It does not tell us the slope of the line or the intercept, right? So suppose that it's a linear relationship, this coefficient does not give us the intercept and the slope of the curve. By producing a linear fitted line for this scatter plot, probably you can look at more or less the slope and the intercept, but still you need to use additional comments for finding those mathematical values. Okay, and the last one, which is really, really important, is to notice that correlation analysis only considers the relationship between the two variables, and it does not imply or confirm any causal relationship. So whenever you are interpreting the correlation, we only interpret the negative or positive correlation, or interpret the magnitude of the correlation and the possible linear or non-linear patterns, but we never say that one variable caused another variable. I have a very classic example to show you. Okay. So By the way, if I do correlation price and price, you will see an exact correlation of 1. So this is a good comment. So the classic example I want to show you is now I'm going to generate a variable that's called the ID number. So the comment is actually generate ID. Of course, you can call it another name. Here, after generation, you just show the variable name. And so equal and an underline n. So this will create the observation, ID observation. So if I click enter, so if you go to the data browser, you're going to see a new ID column is created that is from observation 1 to observation 74. Whenever you feel like you need to create an ID column, this is how you can use the generate to do that. But my example is to find the correlation between ID and MPG. You know that these two variables really, economically speaking, it has no meaningful relationship. But if you calculate the correlation and click enter, it has a pretty strong correlation and is positive. So you do want to be very careful whenever you interpret correlation. Having a correlation that's positive or negative, or even a bigger value, does not mean that the two variables cost one another. So we're never going to interpret or conform any causal relationship here. And in future lectures, I will be introducing the regression analysis, which can identify the causal relationship for us. But this is the limitation for correlation analysis.